Can you screen capture?
All right. So first thing we do is what, Mary? We're going to solve for y. So we're going to, subtract the 7x. I'm gone here. So we get 2y equals negative 7x plus 6. Then what? No, again, we want to get y alone.
Divide by 2.
Yeah. Now remember, you're dividing everything by 2. Just one of them. Both of them. All right, we remember to do that? So this would be y equals negative 7 halves x plus 3. 6 divided by 2. If you want to make it negative 3.5, you can, but I would get in the habit of using a fraction for that number in front of x. Okay? Yes, Chelsea?
Are we able to put the x with the 7 in the numerator? Or?
Yeah, you could do that. If you wanted to put it like that, yeah, that's okay. Just don't put it in the denominator. Gabe, what'd you do first for number 2?
Subtract the x.
Yeah.
Both sides.
Divide by what?
1/2.
Okay, you could do that. What's easier than dividing by a half? Divide by 0.5, yeah, or, Tim? Yeah, multiply by the reciprocal is easier. Reciprocal of 1/2 is what? 2, right? Or 2 over 1. So we get, the 2's and the 1's cancel. This leaves us y. That's our goal. And then distribute. Negative 2x and negative 8. Okay. Making sense? Get in that. You're going to have to do a lot of getting y by itself in this class. Okay. So that says if 3x equals 4y plus 12, find y when x is 0. So all we got to do is put 0 in for x. Which gives us 0 equals 4y plus 12. And then we're going to subtract 12 to solve for y. And get negative 3. So that point would be 0, negative 3, right? So it'd be one down here somewhere. If I had to plot it, that point would be right here, right? And then number 4, which quadrant doesn't that line pass through? 1, 2, 3, or 4? 4. It goes through 1. Here's 1. Let's do different colors. This is quadrant 1. Well, here's 2.
Oh.
And then down here's 3. And down here's 4.
I went backwards.
Okay, so that's where the quadrants are if you have to add no or answer that now. All right, so this little review on some graphing, which we're going to get more and more into. So you want to have your graphing calculator pretty soon. Again, if that's an issue, talk to me. All right, let's take care of that. All right, so that was just a little warm up for what we're going to start getting into today a little bit. For homework, we did page 100, 330 by 3s, and you guys seem to be doing pretty well on that. Seem like you understood. We'll go over number 12. There's a lot of number 12 that left blank. we'll get to that at the end. So we did number 3 was 8, and number 6 was 19.2, and number 9 was negative 21. And then we'll look at 12 after we go through the rest of it. And then 15 is 6.2. 18 is approximately 132. 21 is 36 feet. 24 was 19.75, which, not 19, sorry, 9.75, which is 39/4 if you wrote it as a fraction. 27 is negative 30, and 30 was 600. Any questions on those before we look at number 12, Autumn?
24.
24. That's where we get the 9 plus m. Okay, so that's called a proportion, remember? And so we have to cross multiply. So we go 4 times 9 plus m. So it's like this. We have to distribute it. And then 5 times 15. So we get 36 plus 4m when we distribute. So sometimes we forget to distribute. Okay? And then subtract 36 and divide by 4 to finish it up. Solve for m. What's that? 39. And then divide by 4. So you can leave it as 39/4. That's fine. Or the decimal's 9.75. Or you can put 9 3/4 if you want to write it as a mixed number. Anything else before we look at number 12? Okay. Number 12, we had point A was here, and B was up at 8, wasn't it? Did I remember that right? And C's out here, we're at 7, 6? Negative 6? All right, so 10, 9, 8, 7, 6. And that was C, right? Okay, so it was triangle ABC. So, here we go. Wasn't very straight. That's what it looks like, right? And then D was at 0, 4, wasn't it? Right here. And you had to, it says, ABC has those vertices. Triangle ADE is similar to triangle ABC with a vertex at D, 0, 4. Graph triangle ABC and ADE on the same grid. So E would have to be over here. So you have this triangle, which is the point, what, negative 3, positive 4? It's half as big. Okay. So that's what it would look like for number 12. Anything else? Okay, cool. Today, linear functions. Our objectives: determine whether a function is linear, and graph a linear function given 2 points, a table, an equation, or a point and a slope. So we can graph a line any of those ways. Okay? And we're going to, when you leave today, you should know, you should be able to look at a XY or table, f of x table, and tell if it's a linear function, a straight line. All right, so We're talking about slope, y-intercept, x-intercept, and slope-intercept form, which again should be reviewed for you guys. Most of this chapter, first couple chapters, is this review of Algebra 1 stuff. So functions with a constant rate of change are called linear functions. A linear function can be written in the form f of x equals mx plus b. You're used to seeing y equals mx plus b, right? It's the same thing. X is the independent variable, and m and b are constants. The graph of a linear function is a straight line made up of all points that satisfy that equation. Okay? So, it says determine whether the data set could represent a linear function. So what you do is you look at the change in the x values, and you look at the change in the f of x or the y values, and if the change in the y's divided by the change in the x's are the same, -1/2 in each one, like this, then we can say it is a linear function. Okay, but it's always the y, the bottom row, divided by the top row. If you get that same number, then you can say it's a linear function. This one, the change in our y's, divided by x, that was 2/1, so that's 2. 4/1 is 4, 8/1 is 8. Is it the same each time? No, so it's not a linear function. Okay? Still a function, but it's not linear, not a straight line on your graph. All right, this one, determine the data set. Again, change in the y's, -9, change in x is +7, so -9/7 each time. So we would say, yes, that's linear. All right, if they do it vertically for your table, again, it's still the y's, the one on the right, over the x's, the one on the left. And you check that. Okay? That's actually going to be your slope, right? The constant rate of change is the slope, which we're talking about now. The constant rate of change for a linear function is its slope. The slope of a linear function is the ratio change in f of x over the change in x. Again, f of x is the same as y. Or we'd like to say rise over run, right? Remember, rise is up and down, and run is right and left. Up and down is your y-axis, right and left is your x-axis. It says the slope of a line is the same between any 2 points on the line. You can graph lines by using the slope and the point. So if you know a point on the graph anywhere, from there you can do the slope, rise and run, make another point, rise and run again, make another point. You make a bunch of points, connect them, you got your line. You guys remember how to do that, don't you? Any questions? Too easy, right? All right, so they gave you the point -1, 3. So they plotted it. And they gave it a slope of 5/2. So I rise 5 and I run 2. +5 is up. Positive run is right. Negative rise would be down. Negative run would be left. Okay? So we're going up 5 and right 2. They did that. So then you can connect the points, and there's your line. Simple, right? Question? No question. All right. 3/1, they plotted it. Slope is 4/3, so from there we're going to go up 4 and right 3. They did it a couple times and connect them. Any problems with that if you're given a point and a slope of graphing a line? Okay, negative. Which one's negative? 3, the 4, or both?
3.
3 or 4, doesn't matter. Both, no. What's two negatives? A positive. So you're switching. If you make them both negative. So I'll show you. 0, 2 is here. So if you go up 3, you go left 4. So I did that. Or, oops, go down 3. 1, 2, 3, and right 4. 1, 2, 3, 4. So you end up on the same line, right? Negative slope is always this way. And positive slope is always this way. Okay? So just make one of them negative. Okay, not both. If I did both, down 3 and left 4, see? And it's going to go this way as a positive slope. All right. You can also graph using the x and the y-intercept. The x-intercept is where the line will cross the x-axis. The y-intercept is where the line will cross the y-axis. Okay, always. Y-axis, y-intercept is when x is 0. Always. Okay? X-intercept is some number. Y is always 0. Okay? Any point on the x-axis, that's 4, 0, that's negative 1, 0, that's negative 2, 0, so the y is always 0. Any point here, that's 0, 2, that's 0, negative 1, that's 0, negative 2, the x is 0. Okay? So if you need to find the x-intercept, plug 0 in for y. If you need to find the y-intercept, plug 0 in for x. So, I already have half of each point. Okay, so here's what I do. If it's on my paper, I wrote it down, I put my pencil eraser. If I'm looking for the x-intercept, I put it right over top of that. So you can't see it. 4 times what is 16? 4. So we got that one. Looking for the y-intercept, I cover up that with my pencil, my eraser. Negative 2 times what is 16? Negative 8. It's that quick. Does that make sense? Again, they substituted in and show all that work. You don't really need to. Get your 2 points, connect them, you got your straight line. That's another way to graph. They're going to ask you to graph in those different ways. So be able to do each way. Okay? Again, to find the intercepts, all right? So for the x and the y, all right? So 6 times what is negative 24? Negative 4, right? There you go. Cover up the x. Negative 2 times what is negative 24? Positive 12. So runs off, there's 10, 11, let's say 12 is about there. And then we connect. Okay? So that's using intercepts to graph. Am I going too fast? You okay?
We're good out, we're good.
Okay. All right. Linear functions can also be expressed as linear equations. So there's our y equals mx plus b. When a linear function is written in the form y equals mx plus b, the function is said to be in slope-intercept form. So when you are supposed to put it in slope-intercept form, it's telling you to get y by itself. That's what it means. Once y is by itself, m is the slope, the number in front of the x. If it's a whole number, put it over what to make it a fraction? How do I make a whole number a fraction? Put it over 1. So I got rise and run then. And then B is the y-intercept, where it crosses the y-axis. Okay? Again, solve for y first. Okay? So, to solve for y here, I'd have to add the negative 4, or the 4x. Go to the opposite side, do the opposite. With negative 4x, so we add it, make it positive 4x. So, if I want to make that a fraction, I just put it over 1. So now I have a point and a slope. I can graph it. So, negative 1 is my y-intercept. That's what that b value is. So it's on the y-axis. So always start there, somewhere on the y. And then we'll rise 4 and run 1. 1, 2, 3, 4. You want to go down 4, just go left 1. Okay?
God bless your soul.
Questions?
Nope.
Get y by itself, you should be able to graph. Don't need to do anything else, right? Once you get that done. What is that? 4x minus 1? Just about. Let me show you something now. So that was 4x minus 1. Here's 4. X is right here next to alpha and under mode. Minus 1. Hit enter. And then over here is graphs. You got to hit your y equals button, top left. After you put it in and hit enter, then you hit the graph button, and it should graph it for you. That looks about the same, don't they?
Yeah.
Okay. If you look at your calculator, you hit second. What's the word above graph? Those of you that have them, table. You hit that, it'll show the table. I don't know why it's not showing it here. Here's that's what sometimes it'll show here on the side, the equation, the table, and the graph. I don't know why it did that. But here's our table of values. There's a bunch of points we can plot. Okay? We'll start using this calculator very soon, and it'll help us do some graphs and look at some things. Any questions? All right, the last thing. The slope of a vertical line. Vertical line is which way? Up and down. Is undefined. So your fraction will have a 0 under it if you're trying to write a fraction for it. Okay? The slope of a horizontal line, that's this way. Okay? Your fraction would have 0 in the numerator. Okay? Your y values would be the same for a horizontal line. Your x values are the same for a vertical line. So, a vertical line equation is always x equals some number. A horizontal line's equation always y equals a number. No y in this, no x in that. So what kind is this? Vertical. So it's a straight line, vertical line through what number? 2. So it looks like that. Okay? Y equals negative 4 is the opposite, so that's a horizontal through what? Negative 4. So we have that in blue there. So there's the two lines. Okay, so that's just something you should learn and remember and know. There's gonna be x equals something, some number, just a vertical line through that number. Y equals some number horizontal through that number. There's your assignment.
What time is the bell ring?
43. You got 11 minutes?
Should I head down?
Yeah, you
Huh?
Did you read anything else?
Homework from,
Friday I got.
yeah,
Did you do Thursday too?
I did not get them to do this. I got that. I don't wanna.
Bailey does that.
Right, I got that. That was Friday, do today.
Yeah.
Then we on Thursday, do Friday, you get that one. But then you have to. So when do you want to take it?
When are
I'm here first, fourth, fifth, only period I'm not in here is second, I'm in 234, Mr. Grossman. Second, if you're free second, you can come over there.
I have Glen Oaks as a third period, and then I'm free from 10:30 to 11:40.
Okay, so 4B, subject class. We're gonna just come in 4B, that is done, and after that you can go home. You wanna do it tomorrow or you wanna wait?
I wait till 1:30.
If you got any questions, let me know. We'll go over the practice.
That's what I said.
You did turn that in. Practice.
That's it. Very good.
You see my email over there? Doesn't matter how much like I do something like.